All right, so we're on the back of Worksheet 12. We're looking at a sinusoidal regression question. They give you some data involving the average temperatures for each month. And we're going to enter all of our data that references each month into list 1. Whoops. List 1. And, oh geez. Okay. Let's try this again. List 1. These are all list 1. And we're going from month 1 to month 12. And then carefully typing in your temperatures into list 2. So once your data is entered into list 1 and list 2, on your homework you're not going to probably do this step unless it asks for a scatterplot, which I don't remember if it does or not. But for fun, let's go explore this. So first what I need you to do is go to y equals, make sure that there's nothing in y1. And then I need you to turn on plot 1 and make sure that it's plotting list 1 versus list 2 in a scatterplot. And then you're going to want the window to adjust. If you want it to automatically adjust to the scatter plot, remember we hit zoom and then stat 9, zoom 9. And you're going to see that. Which, since we're in the Trig unit, should resemble one of your Trig things. And I know it's not perfect. So this is the great debate. You're like, is it cosine? Is it sine? Is it cosine? Is it sine? Here's the thing. It doesn't matter because they're both called sinusoidal regressions. Now think about this for a minute, guys. You could be looking at a sine graph and your neighbor could turn and look at it and go, oh, no, that's a cosine graph. You both could argue your points because a cosine graph and sine graphs are really the same cyclical action. Just one's been shifted over a portion of a period. Like think about where a cosine starts versus where a sine starts. So today when we go to write equations, you're going to see the pain that is being a teacher in a PreCalc class. You know, I got to grade your paper or your test, and like you think it's a cosine function, and this dude thinks it's a sine function. This kid thinks it's been shifted left. This kid thinks it's been shifted right with a reflection. And you're all right. So these are fun. Okay, so anyways, your calculator is going to come up with a sinusoidal regression equation, which you're going to command it to do in the stat menu. Go over to calc. And then explore the various types of regressions you have and try to find one that makes sense. Yep. Down there at letter C it says sine reg, which is sinusoidal regression. Now, sinusoidal just means cosine or sine. It's going to come up as a sine function, but like we just said, cosine and sine are really the same shape. So, you got to be careful on that. Don't just think when you guys are writing things for me, if it says it varies sinusoidally, doesn't mean you can't use a cosine function in the future. Okay? So choosing that one. Now this is where it gets a little crazy. Oh, I forgot to do something real quick. Can you guys go to mode? We need to be in Radian mode. We've been working in degree because of the little kid trig we've been doing. But for these regression equations, everything's in terms of pi, which is in radians. So make sure you're in Radian mode, and then also on their next test, I'm going to be really clear and make sure you guys remember that you're going to have to flip between different modes on that test next week. So we got to be careful. All right, back to coming up with the regression. The first word, some people pronounce it iterations, some people pronounce it iterations. I don't really care. The point is it can be anything right now. It's not going to affect your outcome for the regression, so I'm just leaving mine as a default 3. If you're using an older calculator and it doesn't ask you specifically about those, just don't worry about it. Make sure your data is coming from the proper list, though. And then make sure the length of the period is actually blank. Your calculator is going to compute everything for you. I would like you to store the regression equation, always, 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 into y1. Whoops. For Pete's sake. Nope. Clear, quit. There we go. No! Alright, try that again, Abruzzo. Apparently you guys remember how to store. I don't. Let's try this again. Varies, y varies, function, and 1. Now, you definitely want to store these because the functions themselves are incredibly lengthy. Now, when I ask you to write them down on your paper, we're going to have to just agree to round to a certain spot. But this is not anything that you're going to want to manually type in your home screen. All right, let's calculate. Four years later. Okay. I got all those pieces of info. Did you guys get the same? Okay, cool. So the A value is the same A value from original, from our modeling from before. Now be careful, the B in this setup, if you look inside of the sine function, they have it in that unfactored form where the B is being distributed into the phase shift as well. So when we write this down, I don't think there's a case in the future where I ask you to specifically tell me about phase shifting in a regression question. But the phase shift on this question is not just like a negative 1.78. The B value has been multiplied into that. So for some reason you had to identify phase shift, which I'm not going to ask you. You'd have to factor out that B value from it. You'd have to use that negative C over D formula. All right. And then plus D is that vertical shift. So if you go to your y equals, it should be there. Yay. And then go to graph. And then it's going to lap the function through the scatter plot for you. Now, there's no follow-up question on this question. They just wanted you to write down the function. That was on your previous screen. Sorry if you haven't written it down. I'll write it down in a minute. But typically what's going to happen next on a test is then it's going to say make a prediction. Now, this question's kind of lame because I filled in like all of the months for you, like 1 through 12. Typically on a test question, it'll give you like January, March, June, August, December, something like that, and you'll have to figure out some of the missing months. But let's say for funsies, I want to know the temperature according to this model, like smack dab in the middle of March and April. So what number for X would be associated with right in the middle of March and April? Between the 1st of March and 1st of April. 3.5, yeah. So you could do a few things. You could hit trace and then get up on the curve and then type 3.5. Oops, I did 3.55, my bad. But you could have gone to your table and put it in ask mode as well. Got a little happy with the 5s there. Try again. So according to this model, the average temperature was 52.5, like right in the middle of March. So that was kind of a lame question. It didn't actually ask you that on the paper. Sorry, that was my bad. There's some follow-up questions coming up today on our worksheets where we can do another example, or maybe you guys just want to use that time to do your 2 bookwork assignment questions. Remember 20 and 22 on last night's assignment were regression, so I told you to hold off on them. So fingers crossed we have like 5 minutes at the end of today and you can go back and finish those. All right, put that worksheet aside. Oh, I promised you this, didn't I? The formula was, it doesn't tell us where to round. Let's just go 100th. So it was 29.06 sine, and then 0.48 times x minus 1.78 plus 55.83. All right. So let's move along to worksheet 13. 13 is fun. Right there. Now, there's a series of notes that are on a different worksheet in your packet, and you can always reference back to those, but I'm just going to write them here on the slide. 13 is your notes, 14 is going to be your assignment. If you want to jot down some formulas, now would be a good time to jot down some formulas somewhere in the near vicinity of 13. Because so far what we've been doing is looking at the formula and going, oh, A is amplitude, and then we know how to graph it. Well, now we have to think about what if the graph is shown to you. Sometimes you can just inspect the graph, and amplitude's really obvious. And sometimes you might want to calculate it. So what I'm going to do is I'm going to give you a formula for amplitude, which is, it's half of the range. So it's the maximum line minus the minimum line cut in half. So if you think about amplitude, it's the size of your wave from the midline up or the midline down. So vertical shift, or the midline, which we know is this value off to the side here, that can be calculated if you just find the average of the max and the min. So your maximum line plus your minimum line divided by 2. So, period. We know that formula-wise for graphing it's 2 pi divided by b, but I think we have to start thinking about what period actually represents. It's the length of time for one cycle. So you're going to have to figure out through inspecting the graph, how long does it take for it to go through one complete cycle? You guys are good on shape. You know what cosine looks like. You know what sine looks like. You know whether there's a reflection. The phase shift in this formula, they use like x plus c. I just really like you guys to rely back on the fact that, yes, we're always going to use the factored form for these, and that the transformations are going to be exactly what you think they are. So I actually think of this as an x minus c personally, but I don't want to confuse anything with what you learned in trigonometry. So I just want you guys to go back to your roots. Think about transformations. When it's inside with the x, the horizontal transformation is kind of opposite because of a built-in negative. That's the way I always remember it. All right, there's another formula I'd like you to write down, and that's for b. If you think about the formula for period, it was so period is 2 pi divided by b, right? So if you rearrange that proportion and solve for b, you get that b is 2 pi divided by the period. So because of the nature of our questions today, we're going to have to be finding all of these things that we got to place into the equation. So I will warn you, when you guys work on Worksheet 14 for homework, okay, number one, my key is a hot mess. It is like, first of all, the worksheet's kind of ugly because these are really hard to create. So the worksheet's a little nasty. My key is ugly. And all of these questions have various correct answers. So if you look at my key and you're like, that is not at all what I got, because you interpreted it as a different cosine function, or maybe you went shifting left instead of right, doesn't mean you're wrong. It's just going to take a little bit of investigation on your part to figure out if you're right. You can always come in and ask me too. So same goes for today on our problems that we're about to do here. What we come up with in class is really just based on the first person who answers me. So it might not be the question the same way I did this question in first hour, and it might not be the same way that Mrs. Hoffbauer does it in her class, because they all have various answers. So here's the name of the game, guys. You want to make it the least amount of work as possible for you. So the easiest questions on writing equations are ones that start at 0 radians. So if you think your graph, if you could claim it starts at 0 radians for its first point, good. Go with it. So when I look at this graph, are you guys comfortable with me saying something starts right there? And what is that something, by the way? Is this going to be a sine or a cosine if that's my starting point? It's going to be sine. Okay. So you can either circle it or you can write down sine. Now a few more things I want to mark up on my picture. This one's drawn pretty decent actually, but I have a maximum line and a minimum line. Any thoughts as to where they're at? Yeah, I'm thinking 3 and -3. I agree with you there. Now visually, you probably already figured out that that means the middle is at 0. But you could use that new formula for midline where you do max plus min divided by 2. The midline is at 0. You can say plus 0, you can say there's no vertical shift, you can say k equals 0, you can say d equals 0. I don't care, just put something in that line that looks like 0. Now if you guys are claiming that it starts here at 0 radian, that means there's no phase shift. And that makes me happy because that's less work. So the amplitude is the size of your wave from the middle to the height, the top height, or midline to the lower. Your choice. Either way, the amplitude is 3. Okay, period. How long does it take for one cycle to complete? It is your choice where you begin and end the cycle. Since we're starting at 0, that's a really easy place to start. So this, whoops, the sine cycle, oh gosh, okay. It ends right there. Let me erase everything I just did. That was ugly. So the sine cycle starts here and ends right there. So how long did that take? 1 pi, very good. So you're going to write down the period is pi. Unfortunately, that doesn't help me write my equation. So now I'm going to use my new equation for b. B is found by taking 2 pi and dividing by the period that you just found. So what is the value of b? 2. So when I think about what goes in my equation, the amplitude goes in my equation, the b value goes in my equation. If there was a phase shift, it would go in my equation. The midline goes in my equation if there is anything to worry about. And then obviously the type of sinusoidal function you're looking at. So your equation is y equals amplitude 3 sine. Now, because the b value is a 2, And there's no phase shift. I'm just going to write my variable next. I don't think it specifies what variable they want, so if you want to get fancy, you use theta. And there's no phase shift, so I closed it off. And then if you want, you can say plus 0 off to the side, but obviously that's not going to be necessary. That wasn't too bad. All right, this next one. So, it's a little ugly to look at. So I can clearly see where the max and min lines are. And that means that my middle line must be at 0 again. So 0 for the midline. The amplitude is 0.5 of a unit. Yeah. Oh, you know, I haven't talked to you guys about what B actually represents. Does anyone remember from Trig what B represents? Like, we know it changes the period, but it is something. B tells you how many cycles your curve has completed by the time it reaches 2 pi. So when I go back to that question we just did, according to our B value, this curve should have completed 2 full cycles by the time it hits 2 pi. Well, guys, here's 1 pi, and here's 2 pi. Is that true? Did it go through 2 full sine cycles by the time it hit 2 pi? Yeah, so that's what B means. It tells you how many cycles it'll complete by 2 pi. So this one, you can't even see 2 pi. It's not marked, but I can envision it's kind of like here. So we're going to be having a fraction for a B value. So heads up on that one. All right, period. How long does it take for 1 cycle to complete? Well, are you okay with me saying the cycle starts right here at 0? Because that'd be nice. And that means the cycle ends right here. So 6 pi is the period. So using our new calculation for B, that's 2 pi divided by the period. And remember how I warned you it was going to be a fraction? Well, here you go. It's 1/3. So only 1/3 of the cosine cycle is completed by the time you hit 2 pi. That's what that means. And I kind of spilled the beans. Are you guys okay with me calling that cosine? Cool, because that makes it a lot easier. If someone was like, no, Abruzzo, I'd like to call it sine, and I go, well, cool. Now the kid's right, but what else are they going to have to worry about? A phase shift. So why would you want that? So we have no phase shift. All right, let's do this. Whoops. Come on, pen. Settle down. Y equals, I don't care if you change it to 1/2. 0.5 is good for me. 0.5, well, not sine, times the cosine of, and you can say 1/3 theta if you want to get fancy and call it theta over 3. That's okay. Plus 0. All right, a little different happening. I can see the max is at 3. I can see the minimum is at -1. And some of you are really good visualizers, so maybe you already can see that the midline is at 1. But if you couldn't, you could always calculate it. Remember, the midline is max plus min divided by 2, so we would have got a 1 anyways. That is a 1. Can you tell me the size of the amplitude? Yep, 2 units, no matter where you're looking. Alrighty. I hope you're okay with me saying this, the cosine cycle starts here, because that would make my life easier. And that means the cosine cycle ends right there. So the period length is how long? I heard pi over 2, thank you. Alright, little calculation for you. B is 2 pi divided by the period. Now, I don't divide by fractions. Instead, I multiply, and then I take the reciprocal of the second one. So I'm going to multiply it by 2 over pi. And that's going to give me a 4. So according to our new knowledge of what B represents, that means your curve would have gone through 4 full cycles by the time it hit 2 pi. Is that what's going to happen? So like here's pi over 2. It went through 2 cycles by pi, so it would have done 2 more cycles. Yeah, good. Alright, since we decided to go easy, there's no phase shift. And if we're claiming it starts right there, that means you got a cosine. So y equals 2 cosine of 4 theta. And then this time there is a vertical shift of up 1, so make sure you have a plus 1 off to the side there. I'm sure you could imagine that I really prefer this versus yesterday. Yesterday stinks because I can't graph. But I can write an equation with the best of them. I just can't graph. Alright. Ooh. Alright, what's going on? 2 is our max. Does that say -6? Now be careful, all these little tick marks on the y-axis are counting by 2s, so be careful there. Some of you can already visualize where the midline is, but if not, the midline, remember, is max plus min divided by 2. So is that -2? Okay. Since my lines are crooked, it doesn't look right, but I'm going to go with it. The amplitude size is 4 units. This is a good moment to double check all your calculations, guys. It should be 4 units to the max and also 4 units to the minimum. If your middle line happens to be a little crazy, that won't work out. And then the period, oh goodness, thank goodness. You can start at 0 radians. So if I'm going to claim that it starts right here, that means it's going to end right there. And how long did that take for it to go through one cycle? 4 pi, I heard. So what's the b value? So 2 pi divided by 4 pi is going to be a 1/2. Thank you. So again, new definition of b says it went through half of a cycle before it hit 2 pi, which it did. All right, good news. Since because you decided to start here, there's no phase shift. Our midline, you guys calculated at a -2. Come on. And then because we're determining this is the starting point, do you have a sine or a cosine? A sine. Very good. A sine. All right, here we go. Y equals 4 sine. Again, 1/2 theta, or you can go theta over 2, since there's no phase shift. And then a downshift of 2. So what have you noticed we haven't seen yet? A phase shift. Well, let me guess. The next one has a phase shift. Okay. Lots of issues on this question. The first issue being it's photocopied from like a photocopy from a photocopy from a photocopy. So the lines all look weird. Like you probably can't even tell where the axes are. So I think the first thing you guys need to do is figure out and maybe highlight the axes. There's a Y right here with arrows on the end. This is the y-axis. And then here's the arrow with the x. This is the x or radian axis. Which, I don't know what your paper looks like, but on my screen that's really hard to tell. So this is where I get a little sad, because when I look at 0 radians, that is definitely not the start of a cosine or a sine. So, wah. All right. Get a little artistic liberty. Where would you like to start this function? Here? Here? That's exactly where first hour started at. It's magical. I guess my question now is, where is that? Because it's not even labeled. But that's okay, we can figure it out. What's halfway between pi over 2 and 0? That must be pi over 4, okay. So this guy has been shifted to the right pi over 4, according to mine and Olivia's interpretation. Now, maybe the next class does it differently. It's still technically correct, so if you've already worked ahead and you had a different phase shift, it's okay. Let's talk about amplitude. Oh my goodness, that's not even at a normal point. Anyone want to take a guess where they think that amplitude, that top line is? Yeah, it's at 6. This one's at -10. So the midline, which I haven't actually marked yet, is 6 plus -10. Whoops, that's ugly. Divided by 2. So where's your midline at? Oh my gosh, be golly. -2, I heard. Thank you. So now remember, these are counting by 5, so that's awkward. That's another thing this problem has going against it. I can't really tell visually. Like, I feel like I'm kind of okay, but it doesn't help me for counting. So you do have to rely on your formulas here. The amplitude, if this is at -2, the amplitude is 8 units up and 8 units down, so the amplitude is 8. But again, you can use your new formula to calculate it. So if this is where we start the cycle, you have to figure out where one cycle ends. You can choose to move forward or backward, it doesn't matter. I'm going to move backward. Or there's another way to get this right. You can go halfway. Because if you get to the halfway point in the cycle and you can figure out how long that took, you just double it. Alright, we got another layer of fun to this question. They didn't label all your marks, and they're fractions, and they're not common denominators either. Okay, so anyone want to take a stab at either one of these little red stars that I marked up? As far as like how far out they are. What's their coordinate? Did anyone figure out what this one is? Or this one? Say it again. This H block is counting by 1/4 pi. So this one is -3 pi over 4. And this one is -7 pi over 4. Okay. Yuck. Super fun. Okay. Alright, so it's up to you guys. I need to figure out how long it takes for one cycle to complete. You either go halfway and double it, or just keep counting how far away pi over 4 and -7 pi over 4 is. Well, it's 8 pi over 4 apart. 8 pi over 4, better known as 2 pi. Yuck. Alright, so B value. Well, guys, 2 pi divided by 2 pi, that's not very exciting. The B value is a 1. You do have a phase shift. The midline we decided a while ago was at -2. And then because your friends decided to start here, what sort of a graph are you interpreting this as? A cosine. And not just any old cosine. A cosine who's been reflected. So real quick, write down a negative because I'm going to forget. And then the amplitude is 8 times the cosine of. Now there's no B value that has to be factored out because B value is a 1 this time. So you can put a 1 if you want, but it's kind of silly. Talk to me about the phase shift though, guys. Use your knowledge of phase shifting. If you're interpreting it as shifting to the right pi over 4, what does that parenthesis set look like? Minus pi over 4. Very good. That's this guy. And then a vertical shift of down 2. Like I said, definitely not the only answer that's acceptable. When you guys are testing, we're probably going to kind of steer you in one direction. We might give you some ordered pairs on the graph so you don't get too creative with it. And obviously when you're testing, you want to go for the easiest possible answer. So keep that in mind. Oh, fun. All right. Well, the axes are a little easier to see. And everything's counting by 1s on the vertical axes, so that's exciting. I think. So this max line here, this is at 10, and this guy is, oh no, it's not. 1, 2, 3, 4. So your middle would be up at 7, right? Your middle would be at 7. So your midline is up 7. Since I can't draw, this is getting worse and worse. Okay. Well, okay, show of hands. How many of you are just going to just assume that it starts at 0? Yeah, me too. So I'm like, you know, it would really be nice if we just assume it starts at 0. Because if we're assuming that this is the maximum point, like if I draw my dot really, really big, then I'm just going to say it starts at 0. This is a very unclear picture because I can't really tell if that is the actual maximum point on that part of the cycle. I'm going to go with yes. And since I'm the teacher, you get to go with yes too. So there's no phase shift this time, according to your teacher. I wonder if that's how I keyed it last time. Yeah, I did that last time too. All right, the amplitude is from 7 to 10 or 7 to 4. It's 3 units. The period is how long it takes for the cycle to complete. So if this is the start, that means this is the end of the first cycle. How long did that take? 6 pi, very good. So a little calculation for B, 2 pi over 6 pi is 1/3, which means 1/3 of the cycle happened by 2 pi. Here's 2 pi, guys. Is that what's happening? Is that 1/3 of the cosine cycle? Yeah. All right, and then clearly it's cosine because I kind of spilled the beans there, didn't I? All right, here we go. Y equals, it's not reflected this time, 3 cosine of, you can say 1/3 theta. You can get fancy and say theta over 3, and then plus 7. Whew. Lovely. At least it didn't have a phase shift, right? I got one more for you. Oh, and it's about a Ferris wheel. Okay, so this is kind of diving into what we're going to work on Tuesday when I see you next. So if you think about a Ferris wheel, if you're measuring like the height of some stationary part, you know, like the top of the seat or your feet on the Ferris wheel, something, the seat, whatever it is, it's got a sinusoidal action to it. So your Ferris wheel is going to go, assuming it doesn't make any more stops, it's going to go up the Ferris wheel, it's going to reach a peak, and then it's going to come back down. So your height off the ground is going to keep following the same pattern as long as it doesn't speed up, slow down, or stop. So it is sinusoidal in nature. Now the word sinusoidal does not mean you have to use a sine function. You're welcome to use a cosine function. So for us, I'm looking at bottom of the graph here is at 5, and the maximum is at 35. So for the midline, maybe you can visualize it, or else you can calculate it. 35 plus 5 divided by 2 is 20. The amplitude, again, maybe you can visualize it, or else you can calculate it. It's 35 minus 5 over 2, so it's 15. Makes sense. 20 to 25, or 20 to 35 is 15. Anyone know the significance of 15 to the Ferris wheel? I'm hearing things whispered, but I don't know if they're right. What's the highest height you get to on the Ferris wheel is when you're at the top of the circle, right? So 15 would be half of the way through the circle, also known as the radius. It's the radius of your it's the radius of the Ferris wheel according to whatever position you're talking about. With your feet, and it's a little different. All right, anywho. I think we have the information here, guys. Where do you want to start? Please tell me 0. 0. Thank you. It's time of 0. That means it's at the very bottom of the Ferris wheel. Makes sense since you're trying to get on the Ferris wheel. And then we have what kind of graph if we're starting there and then this is the end of one cycle? That must be a upside down cosine. So we have a negative. See, I remembered. What is our amplitude again? 15 cosine of, All right, I'm going to sneak in the plus 20 off. Oh, no, I'm not. Move that over. There we go. Hey, that negative get moved. All right, plus 20. We have not yet calculated the period length, and that first cycle is a little difficult for me to interpret. Like, I'm not really sure if that's a number that I know for a fact, but I'm pretty sure I know this one. Pretty sure this one's a 3.5. But how many cycles were from beginning to 3.5? It went through 2 cycles. So, can you please halvesies that for me? What's 3.5 cut in half? 1.75 is the period. I don't know if I would have guessed that on my graph. It wasn't super awesome. All right, so the B value is 2 pi divided by the period. I might suggest you type in the coefficients. Math enter those, because your B value is going to be a pi number. Is it 8 over 7? Okay, so this is 8 pi over 7. That's your B value, but remember, you still have a variable. Now this question, they were a little loosey-goosey with the formula. They didn't tell you what variables to use, but typically, because these real-life questions are measuring time on these axes, They want you to use a variable that represents time, so usually we go with t. In fact, on your test, I think it very explicitly states use t for time and h for height. So watch out for that. All right, fun time. So you guys can now do, you can complete your bookwork with the sinusoidal regression business. And then, I don't know if this is the right assignment, so hold on, don't copy that. Oh, I think it is. 1, 2, 4, 5, 8, 10, 11, 14. All right, this is worksheet 14, which is the next worksheet. Obviously, it's more writing equations. And you're going to finish page 264. Numbers 20 and 22 are the ones you haven't done yet. Oh, one's crossed off? Oh, I'm sorry. Yep, my bad. One's not there. Ignore. One less question. Excellent.